Today we're going to be taking a look at day 5, so let's see if we can get there. Alright, so day 5 we're going to talk about verifying, and today's kind of like a puzzle. So first we're going to see if you remember this from before, and we'll say that it's in quadrant 2. Now let's mix it up. Let's say it's in quadrant 3. So we have our triangle in quadrant 3, negative 2/3. So what would our y value be? Well, 3 squared equals negative 2 squared plus x squared. So 9 equals 4 plus x squared. So that's going to be 5. So this is root 5, and it would have to be negative. And sine of 2x. So using your formula sheet, this is 2 times the sine of x cosine of x. So this would be 2 negative root 5 over 3 times negative 2 over 3. So 2 times negative 2 times negative root 5 is positive, so 4 root 5 over 9. And then the cosine of 2x. That is equal to our cos squared minus our sine squared. So our cosines, we have negative 2/3 squared minus negative root 5 over 3 squared. So we have 4/9 minus 5/9, so we have negative 1/9. So now what we're going to take a look at is to verify. And our goal, if you take a look ahead here, our goal to verify means show that these two signs are actually the same thing. And here's a couple strategies. Transform the complicated side first. And I always think this means to rewrite in terms of sine and cosine. Work with both sides. Substitute in basic trig identities. For example, we're going to make a list of these basic trig identities. For example, we know the tangent of theta is equal to sine over cosine. That means our cotangent of theta is cosine over sine. We know the secant of theta is 1 over the cosine. The cosecant of theta is 1 over the sine. And then we'll be using this one quite a bit. That sine squared of theta plus cosine squared of theta equals 1. But we'll be using all those variations where if we subtract a cosine, sine squared of theta equals 1 minus the cosine squared of theta. And our cosine squared of theta equals 1 minus the sine squared of theta. So we'll be using all these type of things here. And then we're basically doing some math. We're going to find common denominators, multiply something by 1, and you'll see these as we go through these. So this first one to verify, alright, we can rewrite everything in terms of sine and cosine. So this would be cosine squared of x. This would be sine of x over cosine of x. This is the cotangent. Cotangent would be, or tangent, this one would be cosine of x over sine of x. And it would equal sine squared of x over cosine squared of x. So first step, we have everything in terms of sine and cosine. Well, I look here, well, that's going to be 1. So we have 1 over the cosine squared of x minus 1 equals sine squared of x over cosine squared of x. Well, I notice there's a single fraction here and we have two terms. So let's make over here a single fraction. So if we rewrite 1, this one is 1 over the cosine squared of x. 1 is really, we could have a common denominator of the cosine squared of x. That's equal to 1. So now we have a common denominator, so we have 1 minus the cosine squared of x over the cosine squared of x equals sine squared over cosine squared. So our denominators are the same, so our numerators, 1 minus the cosine squared of x equals the sine squared. Well, that's true because it is the Pythagorean identity. Because if we added the cosine squared, we'd have sine squared plus cosine squared of theta. So this next one, let's see everything in terms of sine and cosine. Well, this is the sine of A. divided by 1 over the sine of A plus the cosine of A over 1 over the cosine of A equals 1 over the sine squared of A minus sine squared of A. Oh no, this is cotangent. So what is cotangent again? Cosine over sine. So cosine squared of A over sine squared of A. So when you divide fractions, you multiply by the reciprocal. So this is really the sine of A times the sine of A over 1 plus the cosine of A times the cosine of A over 1. We have a common denominator here, so it's sine squared of A, 1 minus the cosine squared of A. So this is really sine squared of A plus cosine squared of A equals, well, 1 sine squared plus cosine squared. If I keep going, I know that side equals 1. So we have 1 minus the cosine squared of A equals sine squared of A. So somehow we have to get that side to equal 1. Well, that Pythagorean identity again. We know sine squared of A plus cosine squared of A equals 1. So if we rearrange this, sine squared of A equals 1 minus the cosine squared of A. So this left side, we have 1 equals, we could put sine squared of A on top over sine squared of A, and 1 equals 1. We're going to skip this one for now, and we're going to come back to this one. Find a numerical value of one trig function. So that just means rewrite this with one trig function. So we have cosine of x over sine of x divided by the cosine of x equals 2. Well, we keep our numerator, cosine of x over sine of x, times the reciprocal, 1 over the cosine of x. So that cancels out, reduces down to 1, I should say. So we have 1 over the sine of x equals 2. And this last one, to prove it, well, what does squared mean? Squared means we have it twice. So we have the sine of x plus the cosine of x times the sine of x plus the cosine of x equals 1 plus the sine of 2x. Well, let's multiply this out. So this is sine squared of x. Then we have plus sine of x, cosine of x, plus cosine of x, sine of x, plus cosine squared of x. So I haven't messed with this other side yet. Well, let's see. If we take sine squared plus cosine squared, I know that's 1 plus 2 sine of x's cosine of x's. So one thing I like here, I like how we have the 1 and the sine of 2x. We know that's a double angle identity that equals 2 sine of x cosine of x. So this would be 1 plus 2 sine of x cosine of x.